So I'm here speaking on behalf of the Institute for Economics and Peace. If you're not familiar with our organization, we're a think tank that's based in Sydney in Australia. We're probably most well known for the Global Peace Index. The latest version of the Global Peace Index came out just last year. Sorry, can we reset the timer? Sorry. Excellent, thank you. We are traditionally an organization that does not collect data, or at least does not collect primary data. We are a user and a translator of data from other organizations, many of whom are in the room today. So for example, when I'm producing the Global Peace Index, we rely extensively on ACLED data and on UCP data. However, what we're finding in the era of generative AI is that there are a lot more possibilities and certainly a lot more expectations on the research team in terms of producing data using AI. I'm certainly not the only person in this room who has been asked when it comes to an analysis or data collection task, can't we just use AI for that? If I had $1 for every time I've been asked that, I'd be a rich man. So we've been trying to identify areas in which we can use AI for primary data generation in a way that is methodologically sound, that is feasible, and that is also useful for us as an organization. And the area that we settled on was in relation to human-coded data or expert-coded data. I think most people in the room would be familiar with this kind of data, but if you're not, essentially you have some underlying concept or phenomenon that you want to measure that might be too complex or too abstract to capture with traditional quantitative approaches. You develop a scale which looks at the intensity of this particular phenomenon. Is it low? Is it medium? Is it high? And then you have a human makes a decision, typically for a country-year pairing, where does one country in 1 year sit on this particular scale? And there are different ways of approaching this. So an organization like VDEM is pooling the collected opinions of hundreds or thousands of experts. Organization like the Political Terror Scale has a very well-defined set of inputs that they use to make the assessment. So they're using Amnesty International reports, State Department reports. And then there are lots of course, just private organizations who have fairly opaque methodologies and charge a lot of money for things like country risk reports, geopolitical risk reports. Just bracketing out the methodological concerns with this kind of approach, all of these approaches have a particular problem in common in that it takes a lot of money and it takes a lot of time to produce these kind of indicators. So there's a growing body of literature which is basically looking at, can you use LLMs to do this kind of assessment? To boil it down very crudely, instead of asking a human to make the assessment, you're asking ChatGPT, you're asking Claude, you're asking Gemini. So we're trying to develop a methodology around this. We've tried it in a couple of different ways. So 3 projects that we're using this on. The first, which was the real test case for us, was looking at indicators related to conflict escalation. So looking at the literature on conflict escalation, looking at those factors which were hard to measure quantitatively. So things like fratricidal coercion. So does an army employ blocking units to shoot deserters? The use of heavy weapons by rebel groups. Conflict instrumentalization. So has the conflict evolved beyond the stage of a sort of a local ethnic conflict to be subsumed into a broader ideological conflict and so on. So that was the first approach. The second approach that we've used in the Global Peace Index this year was completely replacing an indicator that we relied on a private subscription service for. It's called intensity of armed conflict. It measures the kind of latent level or ambient level of conflict within a country. So things like if a country's at an institutional impasse, does it have baseline structural grievances? Those kind of things which are hard to capture quantitatively. And then the third approach was looking at, which is currently in development, is looking at the implementation of peace agreements, which is a fairly well-defined problem. It already has an existing scoring scale that we can draw on. So that's what is currently in development for us. So how do you go about putting this kind of thing together using an LLM? So there's a number of different components. Firstly, you need a defined ordinal scale. So you're trying to develop this in a way where it's drawn from the literature. There's also decisions to be made around the number of levels that you use in the scale. There's a trade-off between complexity. If you have too many levels in the scale, it may be more granular, more useful, but then the decisions made by the LLM tend to collapse into each other, for example. You need a detailed coding rubric. And one of the things that we found is particularly important is giving leaving very well-defined event triggers for each level. You want to make the interpretation task for the LLM as simple as possible. So in our intensity of internal conflict scale indicator, for example, level 8, there needs to be evidence of an official state of emergency or similar measures in order for a country to meet that threshold. The third thing you want to do is to have country year anchors. That is to give specific examples to the model of where countries in previous years have met this threshold. So what does it mean for a country to be at level 1, a country to be at level 5, a country to be at level 8? Well, that's equivalent to, say, Northern Ireland in 1971. So it can draw on its training data and use that example to make assessments of other countries in other years. And then finally, in some approaches, you want to develop a set of curated text inputs. So I'm sure many people in the room are familiar with how you set up a RAG. So basically, you're saying the model can only make decisions based on the information that it's specifically been given. But there's also another way to do it, which is sometimes referred to as the LLM as oracle or the LLM as judge approach, where you're essentially letting the LLM be a free-reigning expert, draw on all of its training data. It's not constrained to a particular set of inputs. So this is just an example of some of the ordinal scales for some of the selected projects, how they work, just in the interest of time. I won't go into them too much, but on the left-hand side, example of the scale we use for fratricidal coercion. In the middle, the intensive internal conflict scale that we use. So the kind of meat of the approach is, how do you stop the LLM from doing the kind of LLM things that we're all familiar with, like hallucinating or being overly confident in its results? In a certain sense, hallucination is kind of one of the easier problems to deal with, in that frontier models now tend to hallucinate less, but also that when a model hallucinates, it's either obvious or easily checkable. So if you're doing the intensity of internal conflict indicator score and it says that Australia should be a 9 out of 9 for conflict because the Great Emu War occurred in 2024, you can go back and check the Great Emu War actually occurred in 1932. That's a real thing if anyone's interested in looking that up in Wikipedia afterwards. The real issue is what was mentioned in the first panel discussion yesterday, which is that LLMs will produce plausible sounding results with a great deal of confidence, and then when challenged on it, will withdraw or rescind that assessment immediately. So we're trying to develop a methodology which gets around that problem. We've had a 3-step approach. This is based on the sort of emerging literature on what is best practice in this area. It's a very fast-evolving area, so I'm sure some of this approach is already out of date. But essentially, we force the model to make a level-by-level evaluation. One of the problems is if you ask an LLM to produce a score and a justification at the same time, it will produce the score and then produce a justification for the score. So it's arguing from the score to the evidence rather than from the evidence to the score. So we force the model to make an assessment against all 9 levels in the scale, saying whether the conditions for that score have been partially met, have been fully met, or have not been met. It then takes that evidence from each level and it assembles that into a single thing. In the second stage, it then uses that to make the score. So it's an attempt to try and get the model to argue from evidence to the score rather than the other way around. And then in the third phase, we have what we're calling adjacent boundary rejection, which is just a fancy way of saying if the model gives a score of 5, it has to explicitly justify why it hasn't given a score of 6. So why doesn't this country year pairing meet the criteria for a score of 6? And then why has it exceeded the score for level 4? And all of this creates, if nothing else, at least a paper trail in terms of how a decision has been made. So you have additional information in terms of how, if you're auditing the results, if you want to have a human come in and check the results over the top, there's a process, there's a trail in place, so in order those adjustments can be made. And this is what we ended up with for the intensity of internal conflict score. This is 20 years worth of data for the GPI. I think one of the reasons why this approach is going to become more increasingly common is that you can do this so quickly and so cheaply. In terms of what we were paying for this data previously, being able to produce 20 years worth of data for essentially like 5% of the cost. So in terms of money, it's pennies on the dollar. In terms of time, it's seconds on the hour. Just again, bracketing out the methodological concerns, it's just simply so quick and so powerful to produce data with this kind of approach. I've only got 1 minute left, so it says 3 methodological issues. I certainly wouldn't want to, for the technical people in the room, suggest that these are the only methodological issues. There are lots of methodological issues. What happens if the model you're using is discontinued? That happened to us. What do you set the temperature of the model at? Would you want to be encouraging variation between the same model, or do you want it to produce the exact same results every time? What do you do if for countries where there is just less coverage in the training data and so on. All very good points, all very happy to talk about them later. So with 30 seconds left, I'm actually just going to jump straight to, I think, what is the most important methodological concern, which is that self-consistency does not imply validity. So in doing this approach, we tried to test it to check for validity. So we had various models that we ran it with. We had a human expert, and then we had 2 junior researchers go through the same process with the same scoring scale. What we found is that the models are internally self-consistent. LLMs agree with themselves over different runs. They agree with each other. Claude, Gemini, ChatGPT, they get along famously. When we compared them to our results from our expert, we found that if the question is well-defined, then we see good agreement between experts and LLMs. If you have an indicator which is a bit more conceptually difficult, something like fratricidal coercion, as you can see, there's actually negative agreement in that instance between human and expert coders. So to sum it up very quickly, it's the refrain that you're hearing constantly across most of the presentations. AI can't replace human expertise, but it certainly can supplement. Very happy to discuss any of the methodological issues afterwards. And yes, thank you very much.